Section 1.2 in your textbook talks about scientific attitudes. The essential question we want you to think about is, how does the scientific community and society influence the process of science? The first thing I want you to understand is, what is the process of science? The process of science is the way in which we go about solving a problem. And so in the scientific world, we follow the steps to the scientific method, which start with us stating a problem and go all the way through to coming up with a conclusion. And what we want you to think about is, how does the community around us and society influence that process? That's what we're going to be talking about. And so scientists have to be curious about a topic if they're going to want to learn more about it. And so where do the scientific ideas come from that drive for exploration and investigation? Well, it comes from scientific attitudes. And what we mean by that is, each one of us has to have an internal interest or drive for us to want to know more about a topic. And scientists all around the world are extremely interested in one area of science or another, and they go about performing experiments, sharing their findings with one another to ultimately help us better understand an idea. And when they can share with one another and help each other out, it benefits all of us. And so there's these different attitudes that we want scientists to have when they go about collecting their data and making observations. Because what we want you to remember is this: science stems from our observations, whether they're qualitative, whether they're quantitative, or a little bit of both. That leads us to question just about everything around us. And so you're going to get practice this year collecting qualitative data that are descriptive words, and quantitative data, you taking measurements, quantifying your data to help you solve a problem. And so as we go about solving these problems, scientists all around the world, and as well as you here in class, should have 4 attitudes. The first one being curiosity. I know that not all of you are taking this class because you want to be here. You're taking it because you have to be here. My hope is that you're curious about at least a couple of topics we talk about in class, so you can ask, why is this happening? I want you to learn about topics in class, but also have a better understanding of how it applies to your real world. And so if I can pique your interest in some way, I think I can get you curious about something and want to know more about what is going on. And so hopefully you'll find a couple units interesting, if not all of them, if I do my job correctly. And so curiosity is important. I want you to stop for a minute and think about the last thing that you were curious about. Why did something pique your interest? What made you interested about that topic? That's kind of how scientists feel. They're interested about something and want to know more about it and how it works, so they start looking at the process. That's what we're asking you guys to do. We also want you to be a little bit skeptical. I don't want you to automatically assume everything that I'm saying is correct. I want you to question it. I want you to ask well, why is that true? And how do we know that that's true? Good scientists are skeptics, and that means that they question existing ideas and hypotheses that others have come up with, and refuse to accept explanations if there isn't evidence to support the claim. And so when scientists around the world are performing lab experiments, they need to make sure that they follow a very clear procedure so that other people can follow them. They need to be able to collect their data and organize it in such a way that people can understand it when they look at it and interpret it to find the same results and findings and come to the same conclusions that they came to. Because if other scientists around the world perform the experiment and end up with the same findings, they know they did a good job and did it well. If other people try to follow their experiments and they don't get the same data and they don't come to the same conclusions, that's when people are going to doubt them. And if they disagree with the findings, they're going to design their own experiment and test their own ideas, and they may disprove you. And so skepticism is important. It's an important part of science, and one that needs to be there so that we can question any questions that may arise from any person's lab experiment. We also ask that scientists around the world, and you as well while you're in my class, come with an open mind. Sometimes when we talk about topics in class, you might have a very strong opinion about an idea. I'm asking you that you listen to other people and perhaps listen to their perspective, even if it's one from a different point of view. You might think one way, your neighbor or partner may think another way, and I ask that you both have an open mind so that you are willing to hear each other out and potentially accept different ideas that may not agree with your hypothesis. I'm not asking you to change your mind, but I'm asking you to have an open mind so that you can hear reasons as to why other people feel differently than you. That's an important trait to have, not just in science, but in life in general. So just have an open mind. The last attitude we're asking you guys to have, as well as all scientists, is to be as creative as you possibly can. In your textbook, it talks about how scientists have to try to design experiments that yield accurate data. Of course, we would love any lab that we do to prove what we want it to, but that doesn't always happen. And so if you feel strongly about something, you have to try to be creative and come up with an idea, a lab that others can follow and get results similar to what you have, if not exactly what you have. And sometimes that can be really difficult. Being creative is hard. Coming up with creative ideas to show your point of view can be difficult. But that's why we're going to collaborate together and try to help each other, because two heads are better than one. And in the scientific world, scientists share their data so that they can be as creative as possible with one another to help each other out. And so I've kind of alluded to this before. How do scientists communicate with one another? They have something that's called a peer review. A peer review is where scientists share their findings with the scientific world all over the world by publishing articles. They may publish an article in a scientific journal for other people to read, and then they start to be perhaps a little bit skeptical. They look it over, they repeat the experiment to see if they get the same findings, and so it's published for other people to look at to see if others agree or disagree with it. These scientific papers are reviewed by anonymous, independent experts. We obviously have people that know more about certain areas of science than others. And so these experts from all around the world review it. And here's why they review it. They're looking for any oversights, anything that someone may have missed, an unfair influence that may have affected the data in some way, shape, or form, any fraudulent activity or mistakes and techniques that might have happened, or in terms of reasoning. And so this can be difficult for scientists to hear, but it's an important part of the process. And so one last thing that we need to look at, one topic, is something that's called a bias. In science and in life, a bias is when a person has a particular preference or point of view about a topic or an idea. And so when a scientist is performing an experiment, it's important that their biases don't come into play. Scientific data as a result of a bias could be misinterpreted, it could be misapplied by a scientist who wants a certain outcome or proof. And so a bias, for any of you that don't know, is just kind of like your personal taste or your personal preference for someone or something. And so when your background comes into play, when your personal point of view comes into play, that's when data can sometimes get skewed, or people can start to look at data in a certain way and their reasoning might be off because of their bias. And so we're going to watch this video that's posted here that talks a little bit more about bias to help you better understand it. But the big picture here is, what is the relationship between society and science? They both influence each other in equal ways. Science influences society and vice versa. We're going to look at this not only in Unit 1, but in honestly just about every unit that we do. And you guys are going to be asked to share your views, share your thoughts and opinions, and it might not always be what the majority agrees with, and that's okay. I want you to be able to have these 4 scientific attitudes and be open-minded and be respectful to others that may have a different point of view than you, and just ask that you listen to their point of view to see where others are coming from. That's truly when we have the best opportunity to solve a problem, when everybody can just have an open mind. And so thank you for taking notes on this, and if you have any questions, please let me know. Thanks, everybody.